Question 3 from the AIHL exam is here, which is identical to question 5, I believe, from the, question 5 from the AISL exam. The following recording is my answer to question 5 from the AISL exam. Question 5. A polygraph test is used to determine whether people are telling the truth or not, but is not completely accurate. When a person tells the truth, they have a 20% chance of failing the test. Each test outcome is independent of any previous test outcome. 10 people take a polygraph test and all 10 tell the truth. All right, so let's underline or highlight important information. So we've got a 20% chance of failing the test, even if you tell the truth. Okay, so then therefore we have an 80% chance of passing the test, when they tell the truth, or when these people who are doing the test. Each outcome is independent, right? And we have 10 people taking the test, and they will tell the truth. All right, so we have there's two outcomes in this question. We have passing and failing. Each outcome is independent, and we have a fixed number of trials or of people doing the test, which is 10. All right, so then what this should be indicating to you is that this is a binomial probability question, right? Because these are basically the characteristics or the requirements for a binomial probability question. And the way we denote a binomial probability question is we usually use the random variable x as a bit of a standard in maths. And we put the first number is n, which is going to be the number of trials, and then followed by p, which will be the probability of success or failure. It depends on which way you want to look at it, but that just needs to stay the same each time. All right. So I'm going to head on to the side of we're going to look at it from a passing perspective. Okay. So if 20% chance of failing, that means 0.8 or 80% pass rate. All right, so we're going to say the number of trials is 10. So we've got a fixed number of people, which is 10. We're going to say P is equal to 0.8. All right, so now we can sort of write our binomial distribution as 10 trials with a probability of success or passing it of 0.8. Okay, so part A asks us to calculate the expected number of people who will pass this polygraph test. All right, so let's highlight the expected number of people. Okay, so this the expected number of a binomial distribution is given to you in your formula booklet, which is as follows: is expected number of x is equal to NP. All right, so we can basically bring this over here, and we'll say therefore EX is equal to 10 multiplied by 0.8, which equals 8. All right, and so that's the answer to part A. All right, let's move on to part B. What we got? Calculate the probability that exactly 4 people will fail this polygraph test. Okay, so exactly 4 people will fail. Okay, all right, so if exactly 4 are going to fail, then that means you've got to ask yourself how many will then have to exactly pass, or how many will pass. All right, and that means if we have 10, that means 6 will have to pass. All right, so part B is asking us to calculate probability of x equal to 6. Because we're coming at it from a perspective of passing the test, we're trying to be positive, I suppose. You're more than welcome to look at it from a failing perspective, and you put 0.2 here, and then the question would be you put x is equal to 4 in this bit. All right, but yeah, so we're going to come at it from this perspective. Now, if you don't know how to calculate how to use a binomial distribution, or how to calculate binomial probabilities using your graphics display calculator, using your calculator, I would advise you look that up on YouTube or wherever, find a manual and find out how to find binomial probabilities. It's very important for the course. Okay, so I have this little app here, okay, binomial or probability distributions. And so we're going to come down to binomial distribution. We had the number of trials being 10, probability of success being 0.8, and then our number x is equal to 6. You're going to make sure that you've got x is equal to here. All right, and there we have our answer, 0.088080. And if we round that to 3 significant figures, we'll get 0.0881. All right, so that will be our answer to part B. All right, so here we go, 0.0881. All right, lovely. Now let's move on to part C. Determine the probability that fewer than 7 people will pass this polygraph test. Let's highlight the idea of fewer than 7 people, and actually, yeah, will pass. Right. So if we write that down here, all right, so this question is asking us to find when the probability of x is less than 7. So you'll notice that on my little calculator here, when I go less than, I have to add in the equal sign here, okay? So in order to calculate that, I'm going to have to say, because we've got discrete data here, all right, so one person counts for one person, we can't have half a person. This probability is going to be the same as x being less than or equal to 6. And funnily enough, it's the same number from last time, so I've actually got that over here. And that turns out to be 0.121, rounded to 3 significant figures. Let's put that in 0.121. Okay, and so that is the answer to question 5. I will stress that if you don't know how to find these out with your calculator, to research that yourself, because every calculator is a little bit different, and your calculator will be able to do most of the heavy lifting in this question for you. Okay, so let's move on.